So this is part B of the camera project, and so we want to model the shutter closing. The steps are, first we're going to model a spring, which we've just done in the first video. Next we want to model arc length. Then we need a model of the force as an equation of theta, which is my angle. And then lastly, we need to model the dynamic equation of the shutter closing. So we've got these 4 steps. So the second step is to start thinking about arc length. So if we look at our shutter, you can think of it as a small little lever arm given by R, a longer lever arm given by L with this kind of shutter closing piece which has a mass, and this shutter rotates about this fixed pivot point. And it closes very quickly because the spring pulls on the system and closes the system. So the shutter is going to swing shut to the right. And it's going to swing shut by, it starts at 150 degrees, and then it's going to swing shut to 180 degrees. Here's my spring force. And it's going to swing shut to 180 degrees. So we want to model this shutter, and we want it to swing closed, and basically we want to model this movement here. So if we think of arc length, if we think of something with a radius given by R, and it's going to rotate like that, this distance here is arc length. That distance is arc length, and it typically is measured by that delta R for arc length is going to be measured by a radius times an angular deflection, and we're going to put pi minus theta as my angular deflection. So if I look at this system, again, the system snaps shut. So we're going to model this system where this lever here is at 180 degrees. It swings up to 150 and then snaps back. It swings up to 150 and snaps back. We are going to assume that this spring is always perpendicular to this lever arm because that's for ease of calculation. If you wanted to do something fancier, you could, but we don't need to. This is the length. This is my pivot point. This is the length L. This is my length R. It's going to be, it's going to go to 150 degrees and snap back. 150 degrees and snap back. What I did was I measured this distance of the spring, and then I rotated it and also measured that distance of the spring, and I'll get into that later.